Hi everyone, I am Dr. K. Kritika, Associate Professor, Department of Mathematics, K.S.Rangasamy College of Technology. Now I am going to take the topic chi-square test from the subject statistics. In this testing of hypothesis, there are two samples. One is small sample, another one is large sample. The sample size n is less than or equal to 30 means it is called small sample. The sample size n is greater than 30 means it is called the large sample. Under the small sample, there are three tests. One is t-test, second one is f-test, third one is chi-square test. So now we are going to discuss only about the chi-square test. In this chi-square test, there are two types. The type 1 name is chi-square test of goodness of fit. So here, the chi-square test formula is, it means that the test statistics is chi-square is equal to summation of O minus E whole squared whole thing divided by E. O means observed frequency, E means expected frequency. In this type 1, the degrees of freedom is n minus 1. So the first problem is, the following table gives the number of aircraft accidents that occur during the various days of the week. Test whether the accidents are uniformly distributed over the week. So here, two data are given. One is days, Monday to Saturday, and another one is the corresponding number of accidents are given here. So this 14 accidents occurred in Monday, and 18 occurred in Tuesday, and etc. up to 14 occurred in Saturday. So solution. So step 1 is we define the null hypothesis. So from the problem we can define the null hypothesis. So here the accidents are uniformly distributed over the week is considered as a null hypothesis. Step 2. Actually these given data are called the observed frequency. So using this observed frequency we are going to find the expected frequency. The formula is summation O by n. So here we add all these observed frequency divided by number of data is 6. So value is 14. Step 3. Now we draw one tabular column. In the first column, the observed frequency, which is nothing but the given data. Expected frequencies, just now we find 14, 14, 14. So in all these observed frequency, the expected frequency is a constant. Then in the third column, we calculate O minus E whole square. Then the final one is O minus E whole square by E. Now we add all these data. It means summation of this one. Its value is 2.143. Actually, this 2.143 is nothing but chi-square test value. After we finding the calculated value, we move to step 4. Here, the degrees of freedom is n minus 1. So, n means number of data. So, 6 minus 1 is equal to 5. The level of significance alpha 5% is 0.05. Now, we are going to write the table value of chi-square at 5% level with the degrees of freedom 5 is 11.07. This value, we can write this 11.07 from the chi-square table. Step 5, conclusion. Here, the calculated value of chi-square is 2.143. So, the 2.143 is obviously less than 11.07. So, calculated value is less than table value of chi-square means H0 is accepted. So, that is the accidents are uniformly distributed over the week. This is the same, this is the second problem, same type. Do it yourself. Now we come to the third problem. The theory predicts of the proportion of beans in the four groups A, B, C, D should be 9:3:3:1. In an experiment with 1600 beans, the numbers in the four groups were 882, 313, 287 and 118. Does the experimental result support the theory? So here in this problem, null hypothesis is the experimental result support the theory. In step 2, we are going to find the expected frequency. Actually, this 14,600 beans are given in the four different groups in the ratio 9:3:3:1. So here in this problem, the expected frequencies are 9 divided by the total number of this one is 16 into 1600. So you're getting 900. Same, the second expected frequency is this 3 divided by the total number of this ratio is 16. So 3 by 16 into 1600 is equal to 300. Similarly, the next one is also 3. So 3 divided by total number of ratio is 16. So divided by 16 into 1600 beans. So multiplying by 1600, again we getting 300. The last one is 1 by 16 into 1600 is 100. Now we move to step 3. Step 3 is nothing but the tabular column. In the first column, we write the observed frequency. Actually, these are the observed frequency. This given data are nothing but observed frequency. So in the first column, we write O. In the second column, expected frequency. Then similarly, O minus E whole square, we find. Then O minus E whole square by E. So sum of these O minus E whole square by E value is 4.726. This term is denoted as chi-square. So chi-square value is 4.726. So in step 4, we write the degrees of freedom. So actually this is type 1. So degrees of freedom is n minus 1. So its value is 3. The level of significance, same, 5%, which is equal to 0.05. So from the table, we can write the table value. It is 7.81. Conclusion. Step 5 is conclusion. So here, the calculated value is 4 point something, but table value is 7 point something. So definitely calculated value is less than table value of chi-square. So H0 is accepted. That is, the experimental results support the theory. So now we move to the second type, chi-square test for independence of attributes. So here, chi-square formula is same one, summation O minus E whole square by E. But the degrees of freedom is R minus 1 into C minus 1. R means number of rows, C means number of columns. So in the second type of chi-square, we always take the hypothesis, null hypothesis is the given two attributes are independent. So this is the first problem. So here one contingency table is given here. So here we are discussing about the hair color and eye color. So using this chi-square, is there good association between the two? So in this problem, the step 1 is null hypothesis. Actually, this is actually one table, contingency table is given. So definitely this is second type of chi-square. So here null hypothesis is the given two attributes are independent. So in step 2, we calculate the expected frequency. So here 1, 2, 3, 3 into 3, 9 data are given. These 9 data are nothing but observed frequency. Now we are going to find the expected frequency of each observed frequency. So here the first observed frequency is 15. So the expected frequency for this observed one is 40 into 60 divided by the whole total 150. Similarly, the expected frequency of this 5 is this 30 into this 40 whole thing divided by 150. Similarly, the third expected frequency of this observed is 40 into 60 whole thing divided by 150. Similarly, here, suppose if we take this 15 means, what is the expected frequency of this 15 means, the 60 into this 30 whole thing divided by 150. So in this way, we are going to find the expected frequency. So step 3 is same tabular column. In the first column, we write the observed frequency. In the second column, we write the expected frequency. In the third column, we calculate O minus E whole square. In the fourth column, we calculate O minus E whole square by E. The summation of this value is 3.6458. So which is nothing but chi-square test. So here the degrees of freedom is R minus 1 into C minus 1. So in the contingency table, the number of rows is 3, number of columns is 3. So 3 minus 1 into 3 minus 1 is equal to 4. So here also the level of significance is 0.05. The table value of chi-square at 5% level with the degrees of freedom 4 is 9.488. So here also the calculated value of chi-square is less than table value of chi-square. So here H0 is accepted. Suppose calculated value is greater than table value means the conclusion is H0 is rejected. So but here it is less than. So H0 is accepted. That is, the given two attributes are independent. Hope everyone understood. Thank you.